Hey guys,
Hi.
welcome to today's podcast with the Dazzling Dendrites. Now we're going to talk about glutamate. What's glutamate? It's the main excitatory neurotransmitter in the central nervous system. Now for review, what's a neurotransmitter? They are body's chemical messengers. What does it mean when they're excitatory? They're responsible for exciting the neuron, leading to the message being fired off. Okay, so glutamate helps your body send messages. So what? We have a million neurotransmitters. Why do we care about this one? Well, for today's podcast, we care about glutamate because it's involved in numerous higher functions, such as memory, learning, and attention. So I hope everyone's paying attention because now we're going to talk about neuroplasticity and glutamate. Review time. What's neuroplasticity? It's the ability of your nervous system to change its activity in response to stimuli by reorganizing its structure and functions. An example we can consider is looking at the aftermath of a TBI. Following this event, several changes occurred in the brain. Now it's time for neuroplasticity to kick in and start adapting to these changes and reorganizing itself for upcoming functions. So how are glutamate and neuroplasticity connected? Glutamate is involved in those higher functions like memory, and those functions depend on neuroplasticity to be able to adapt to environmental factors. So Lauren, what properties does glutamate have that makes it different from other neurotransmitters?
Glutamate is the most common excitatory neurotransmitter in the brain, being responsible for 90% of excitatory functions in the central nervous system. Something interesting about glutamate that distinguishes it from other neurotransmitters is that it's able to bind to several different receptors. So essentially, this means that glutamate is easily able to communicate with and carry a chemical message to other neurons. Glutamate's ability to bind to its receptors is often compared to a lock and key analogy because of its compatibility with its receptors. For example, a key being the neurotransmitter glutamate, and it's able to unlock several doors, the doors being the receptors. Glutamate also functions as an amino acid. This means it can be consumed through our diet and synthesized in the brain. Glial cells convert glutamate to glutamine, the amino acid, and then glutamine gets put back into the neuron and becomes glutamate. So Rosie, what is glutamate's relationship to speech, language, or hearing disorders?
Well, we're all prone to change, at least we like to think that we can. Glutamate regulates this neuroplasticity, especially in the spaces between each neuron. When glutamate is released from the end of one neuron into this space, it requires a receptor, a door, such as AMPA, NMDA, or a kainate, at the start of the next. The NMDA channel specifically protects against cell death by transcribing new genes. When glutamate interacts with one of these receptors, the channel can accept positive sodium ions coming in from the space between, providing the voltage needed to push the messages down the line, so the message can continue throughout the brain, efficiently connecting our learning and language centers. So, Chanel, how does knowing about glutamate help improve clinical practice?
Well, Rosie, there are many ways understanding the role of glutamate can help improve clinical practices, but here are a few. For starters, it can help with diagnostic precision. Knowledge about the involvement of glutamate in language processing and disorders can aid in the development of more precise diagnostic tools. Researchers can explore biomarkers related to glutamate function, such as specific event-related potential patterns, to improve the accuracy of language disorder diagnoses. Next, it can greatly assist with pharmacological interventions. Glutamate is a crucial neurotransmitter in the brain, and its dysregulation has been implicated in various neurological and psychiatric disorders. Understanding the role of glutamate can guide the development of pharmacological interventions. For instance, drugs that modulate glutamate receptors or glutamate levels may be explored as potential treatments for language disorders. And last but not least, it can contribute to the selection of therapeutic approaches. Clinicians can integrate this knowledge into therapeutic approaches for individuals with language disorders. Speech and language therapy programs could be designed to target specific aspects of glutamate-related language processing deficits. This personalized approach may lead to more effective interventions. And that's a wrap of today's episode with the Dazzling Dendrites. We hope you've enjoyed diving deep into the fascinating world of glutamate with us. It's truly a neurotransmitter that plays a vital role in our brain's function and has far-reaching implications for our health and well-being. Bye!
Bye!